have this guy? Yeah?
I'm confused. Is it a cube or a diamond?
A cube is a diamond. And no, it's not even a cube, it's a square, because a cube is a 3D. No, it's not a cube.
No, it's not a cube.
It's a square.
Square. Cube is going to be 3D. Okay. So a couple of things that are important to realize with what we're doing right now is that the area of a square is the side length squared. So one formula that we have for the area of a square is this. Last year, we worked back out of this using the radical symbol. And we said that if we knew, for example, that the area of the square was 25, that because the square root of s squared is s, then the square root of 25, being 5, is the solution to such problem. Now, this has to be over here. Is this going to be a real problem? I'm close to hanging it on the ceiling. It just hasn't happened yet. So it's that way in the other room. It's really, really nice. So with that, we were working here. Let's see if I can drag this thing forward a little bit. We were looking at this, and we're going to add a bunch to this, a bunch of information. We came up with the fact that that square in the center had a side length of 5. We measured it, and there's a couple of ways of figuring out that it's 25. So for example, this is 3 by 4, one of these little right triangles. Yes?
Yes.
How many of those triangles are in this large square?
4.
There are 4. So the area of one of these is 3 times 4 divided by 2, which is 6. So this one has an area of 6. What's the area of that one?
6.
Total, that makes
12.
And then these two,
24.
total of 24, 6 and 6 again. So you have 4 of them that are 6. So if you took those 4, which have an area of 24, and you subtracted it from the area of this big square, that tells us that in the middle, that has to have an area of 25. Agreed? Okay, so, we can measure that this is 5. We can do the subtraction here and figure out that that's 25 for an area. And, and then from that 25, we can work backwards here. We can find that the side length is 5. So there's lots of ways to verify this. It is what it is. So how do you calculate how long the side lengths of these small triangles are? How do you figure out what they are? This is 3, this is 4, and this is 5. So what's the relationship? I had that written down somewhere, right? Oh, here it is. Yeah, duh. Okay, good. Yeah, well, if you take this side length, which is 3, and you square it, that's 9. You take that and you square it, that's 16. And if you add those two squared values together, it should be equal to the third side squared. So then we look at 6 squared plus 8 squared. Does that equal 10 squared? We said that, yes, and then we walked out of here yesterday. That's as far as we got. But there's lots and lots and lots of different possible, what we call Pythagorean triples. And a Pythagorean triple is a set of 3 whole numbers that are possible measurements for right triangles. This only works for right triangles, you guys. It doesn't work for anything else.
How do you find the length of a triangle?
I'm sorry?
Not right. How do you find like the side length of a triangle that's not?
So if I had a triangle like this, and this was 10 and this was 12, how do I figure that?
Yes.
3 more years and I'll teach you. Yeah, that gets complicated. we use something called law of sines to figure that out. And we can actually figure it out with law of cosines too. It's a little longer, but yeah, those are things that are pretty complicated relationships that we're not ready for yet. We've got to do a lot more work. So in your notes, we need to have this information here. For all right triangles, this is the Pythagorean theorem. These are the legs. The legs are at 90 degrees to one another. And if we were to call the legs A and B, and then we call the hypotenuse C, and we can use any letter set that we want. We could use X, Y, and Z. It doesn't matter. If we took that first leg squared, and we added it to the second leg squared, it will always equal the hypotenuse squared. Always. A squared plus B squared is equal to C squared. That's the Pythagorean theorem. So that's what you need to know. That's your notes for this lesson. It's a formula. Pythagoras figured this out 2,700 years ago. And it works for every single triangle.
Right triangle.
Right triangle, yeah, every single right triangle. Oh.
What if it's 89.98?
What's that?
What if it's 89.98?
It doesn't work. Yeah, if it's 89.999999, it doesn't work. It's got to be a 90-degree angle. So you guys have one of your little right triangles, right? Or you could make another one quite easily. Here's what I'd like you to do. So a 3, 4, 5 is really nice because it's the smallest numbers that we can use for a Pythagorean triple, and it's easy to work with as a construction. So what I'd like you to do is I'd like you to take a 3 by 3 square and a 4 by 4 square and a 5 by 5 square in grid paper and arrange them like this, because this is another way to arrange it and see this relationship. Because if you have this square here, this is 4 squared, which is 16. And then you have here 3 squared, which is 9. And then this is going to be 5 squared, which is 25. It's another way to witness this.
Are we drawing that?
Yeah, can you cut those out of your grid paper and put them together in your notebook so you have a little diagram of that in your notebook as well? And if you need more grid paper, I've got it up here. And the scissors are still here. And there's glue in different boxes. There's glue here. Yeah, exactly. So you need a 3 by 3, 4 by 4, and a 5 by 5 square. Yeah, and you know, can I steal your stuff there for a second, Lucia? You see what Lucia's doing here? She just took a fresh piece of graph paper and she put her 3x4 right triangle and then just used the grid paper to square off a 3x3 and a 4x4. And then you could easily just cut out a 5x5 and just tape it right over the top of that. So what she did this on grid paper. All of this, everything except for the c squared. So that's a 3x3. So how are you going to start yours? You going to do it like Lucia did, or are you going to cut them all out separate? Okay, then you need a 3x3, a 4x4, and then the right triangle.
Oops, sorry. Yesterday.
Give me a second.
Should we shade this too? Shade it.
No, you don't need to shade them. That was just so we could see them a little bit better. Hey, you probably know this already, but I just want to make sure I tell you. The school computers that we have in the cart are not to go home with you at night. Yes?
Yes.
You know that? Okay, because I know some have been. Some people have been just taking them home and bringing them back the next day, but please do not do that. It's critical for how we manage things around here that they stay in the building right now, okay?
Okay.
Thank you. And another thing that's really important with the way we're operating now is that your math things can be in this room. Like, you can leave them here, that's cool. But make sure that any notebooks that you have and your calculator and your textbook all have your name on them for all classes. Make sure that you've got your name on things. So if for some reason or another we need to find your things for you, we know whose notebook is whose, and we can get them all. You've got to maintain organization. And if you need a Sharpie or anything to label, just ask. Oh, there is? You just get under the table, we have nice big tables, sort of. Yeah, earthquake drill. I suppose they're all on the calendar now. Yeah, earthquake drill's pretty straightforward.
On the diary.
I don't know, it's just sometimes it's.
Oh, yeah, if there's a lockdown though. Oh, what do you do here, huh?
We go in that room.
No, we don't go in that room.
That's what we go
No,
in.
but that's not what we're doing. We're going down into the kitty corner,
Oh.
all the way down that way. Because that doesn't back us into a corner. We have options to leave if we need to or want to. Because there's a door down there, and then there's a door up here. We're not stuck in a dead end. And we're also not packed into a tiny little place together. So it's real simple. If we have a lockdown, what you want to do is just leave your things where they are. And just walk all the way down to the end and have a seat down on the floor down there, quietly. And then we wait. You know, no shades to draw, the door will get closed. Yeah. And then you listen. So where are we at with this? Are we there? Are we close? Some of you are there. Some of you would be able to glue this down if you wanted to, as another model of the relationship between the side lengths of right triangles.
Oh, I do.
So some of you are there, some of you are still putting it together. I'll give you another minute or two, and then I want to show you something else before we start our homework. And some of you will have to just stop what you're doing and then pick up and finish it.
Can I use this?
Yeah, definitely. That's why it's out.
Kind of nice having math as your first class because it kind of gets your brain going.
This first class, you like this?
It's not the worst.
There you go. Cool her down. Looks good.
Should I cut them off or just?
No, you can, they're fine the way they are. No need. Yeah. We got a meet, huh? When?
Yeah, we were talking about
We gotta slot together an agenda. What do we need to talk about?
We need to get the members for the committees, but that's really hard because, you know, we're not allowed to do anything in school days or committees in lunch, committees in nutrition, we can't do anything in classes, nobody's on Saturday. Yeah, you just feel like sign up for a committee.
So what we need to do is back up and think about
and we can send out a survey.
ideas of what can be done. Yeah, I'd like the two of them.
Okay.
This is what we had in the past. Don't say what we can't do. Let's just say, what do you want to do? Because maybe somebody wants to do something, we can find a way to make it happen.
Maybe can we send out like a Google survey about who wants to like join what thing, and like we've always done, about what they want to do, and just put them out and use them.
We should have a, input box.
Test your
These
survey,
ideas.
play with your survey between the two of you, so you know what it looks like when they see it, when it comes back.
Okay.
So you don't know what your college junk, it takes more time to straighten out after you get it. So that's what the survey will look like first.
So, can we do a meeting on Friday or eight?
We glue this down. Or no, what?
If you get your survey back by then, today's Wednesday.
We could
I
probably
told
just
search
send it out
and
today.
put
Blue.
Yeah, we could send it out today and
And
then
white.
teachers not having anybody fill it out.
Oh, I found where my
Yeah,
science
maybe.
notebook went.
Problem is, then that falls upon one or two teachers, because I only see you guys in the morning, so I don't see you guys.
So we just tell them to like, we could go around and remind all the students.
See how fast you can get it together, and then communicate with you, okay? Get your survey ready to go first. Yeah, I know, I'm gonna push it to Friday, I'm thinking more and more, we have a 4-day weekend, I don't wanna,
Oh, I
so I
forgot.
think I'm just gonna let it go at the end of the week.
I forgot about that.
Yeah, yesterday I didn't wanna break what we were doing, I wanted to have closure. And then I think we just have closure with this whole Pythagorean thing. Okay, I know some of you are still gluing them in, and that's cool, but could you hold on, finish that in a moment, and come back up here with me? So, there's lots of kinds of problems that you're gonna come up with this. And some of the problems are gonna require that you know the triangle sum theorem. No, triangle sum
Subscribe.
theorem, yeah, which is this. If you have 3 angle measurements inside of a triangle, they are going to add up to how many degrees? We did this last year. They come up to 180, yes. The interior measures of any triangles add to 180 degrees. So if, for example, we had 30 here and maybe this is 60, ooh, that's not a very pretty triangle. I don't want to call that 60. Let's say that this is 45. Let's say that this is 50. If that's 50 and this is 45, what does the third angle have to be?
Okay. 85.
95?
95.
Yeah, this has got to be 95.
Same.
So you might want to write this down, that the sum of the interior angles of a triangle is 180 degrees.
But that would make it work.
Is that 190?
Yeah.
And that does not look like 90.
Oh, so then this can't be 95, it's gotta be
85.
85. Did you say that and I didn't hear it?
I said that.
You said that and you said it, I
I got
didn't hear it.
confused.
Okay, so it's gotta be 180 degrees. You guys have all kinds of paper and scissors in front of you, right?
Yeah. Paper.
Take a piece of paper, take a scissors, use the corner of your paper as like one corner of a triangle. And then you can fold your paper, or you could use a straight edge. You can either fold your paper or use a straight edge to create a triangle. And I'd like you to either cut it or tear it very, very accurately. Can you do that? So I'm just gonna crease mine like this.
Have to be a nice triangle.
Well, it doesn't have to be, it can be any triangle. Good room type. And if you wanna cut it, you can cut it. If you want to tear it, and you can tear it real accurately, tear it away. How big does it have to be? Not very big.
What's your
In
percent?
fact, I'm gonna make mine really small like this. This is the one I'm gonna use.
Love that. Sorry. So I could use that.
Yeah, you can use whatever you have. All you, just big enough that if you tear the corners off of it, you can still see them. So if you take a little triangle like this right here, and then tear the corners, so that when you tear them, you know which corner of your little torn piece came from the triangle. That's important. So I've got one piece, I've got two pieces, and then I've got the third piece. Save the corners, get rid of the middle of your triangle, and use those pieces to prove that you have 180 degrees total for your three corners of a triangle. So you have your corners, so carry the 3 corners off.
They have to be nice and
We
Okay,
make a
that's
little
good, as long as you
triangle
can
and
see
then
'em.
we just take off the
Don't
tips.
cut them, tear them. If you cut them, you won't know which corner came from the triangle. So now you have 3 little points. There you go, you got it.
Wait, how will?
With all 3 words?
So you take those
I
3
made
little
mine
points
like
and put them together.
this. And then
How many degrees do you have?
only 180, but you know.
The points are not together right now. Here's a point,
Yeah.
and then here's a point.
Oh, it's actually flat, isn't it?
Yeah, the flat edges are gonna come together.
I thought you were talking about like the rough edges.
So here's your other point.
should we
And now you have 2 points together here, and then you have to get the 3rd point in.
Let's pretend this is straight line.
Line them up. You look like a 180.
1, 2, 3. Yeah, that's funny.
Yours work? I will.
Mine is just really.
Take the
See,
3 points
that's
and put the
straight in,
points together.
that's straight in.
How does this look so much better than that?
That's a triangle.
It's not really evidence to be honest.
Okay.
It's a triangle with a flat head.
How do you make all?
Whoa,
I know, I
Phoenix.
got one.
Wait, what do we?
Yours?
Like a square. Wait, what are we doing? No, what's the triangle? Like, how big is the triangle?
It's just whatever you want it to be. You don't cut it, but you like fold it.
Here's the points of your triangle.
You fold it, see?
There's the other. Put the points together.
You do cut it out.
Or is that one? Probably take
And get the point of this one slotted in there.
I'll probably swatch it.
Oh, that is not a triangle.
Yeah, it's fine. Where, oh, you must come off. You can't cut them
Should be. I gotta finish right here.
off. Now I don't know where the corners of your triangle came from.
Oh,
You just need your colored corners,
oh yeah.
so you need just one triangle. So, cut that and you've got one triangle, you've got 2 right there.
Oh,
So you have them
You just want one.
all together?
just cut
Yep.
that right here. Okay.
You got them all together? That's all good, 180. Yours are right. Rylan, you have yours laid out?
Just that off and just cut it out.
Okay, thank you.
So you have to have all the points together at the same location.
Yeah.
All of the vertices of the triangle. This is a vertex of the triangle, right? So where's another one?
Now you put all the.
That one is, which, what is it this? Like that? Now spin that around. And then you have this side. Yeah, look at the corner, just a minute. Keep going, keep going. There you go, now spin it. What do you have?
I know, I heard you guys.
You have them? You need a triangle. A triangle, yeah.
I have it. I have it.
Do you?
So this triangle underneath.
That's what I ended up with there.
Now tear off
Look,
edges,
Pretend that's a
So
doesn't matter
just
what
tear off
size.
the horns.
You just want
Yes.
to kind of make it, no, don't fold it, just tear it.
and then
Just tear off.
what I have is all 3 of the vertices of the triangle that are all brought together here. And they form a 180 degree angle.
Now you can tell that that would be a point of the triangle.
There we
So
go.
do that
That
one
looks
on it.
So that's proof that any triangle will have the sum of the 3 angles being equal to 180 degrees. You'll read that for the problems in this lesson.
The edges of your triangle together, with the points all coming together.
So, you have it? Do you have it now? Phoenix?
Yeah.
Yes?
Write it. That's
Yes?
what I did.
Yes, yes, yes.
I did.
You got yours lined up? Willow? Did you get yours lined up? Okay. All right, so, now, how do you work with the Pythagorean theorem? Okay, so first of all, one question is going to be, can you use the Pythagorean theorem to figure out the side lengths of this triangle? Yes or no? No.
Oh.
Because the first thing is that the Pythagorean theorem only works for
Right,
Right triangles. They have to have a 90-degree angle. If they don't, you can't use it. So this only works for right triangles. Who has a parent that works in construction? So you just go home and say, hey, what do you know about a 3, 4, 5 triangle? And they'll just look at it and they'll go, I can use it every day. Because what people will do in construction, if they're laying out walls, for example, and they want to know that they come together square at a 90-degree angle, they'll take a big sheet of like plywood and cut it into 3 pieces that are 3 feet, 4 feet, and 5 feet, and they screw them together into a big, huge triangle like this. And then that gets used as a square. And they do that when they lay out roofs as well, to make sure that the corners are square, to make sure that the metal comes down square on the roof. So you can't use a little square that's, you know, this big. They do that for small cuts of wood, but when they're laying out walls or they're laying out larger things, this is what they use. Now, keep this in mind. If something is square like this, in all 4 corners, there's going to be a diagonal that can be drawn. And that diagonal is going to be the hypotenuse of a right triangle. So if you were standing out on the football field, for example, and you're on one corner and you were going to travel to the opposite side's far corner, it would be like you're walking along the hypotenuse of a really big triangle. So if you had, for example, a 100-yard football field, they're 50 yards wide, conveniently. The question is, how far is this in yards? So here's how you set this up. First of all, if we call this side one leg and this side the other leg, pay attention up here. You gotta look at what I'm pointing at. That's gonna fit this pattern or this formula. These are the sum of the squares of the legs. So if we took 100 yards, and I'm just, for convenience, I'm just gonna write the numbers, not the units. If we took 100 yards squared plus 50 yards squared, then we can call this C. That's gonna be equal to that length squared. So this is what your work should look like when you do it. So what's 100 squared? 100 times 100.
1,000.
10,000.
Oh.
10 times 10 times 10 times 10. 2 place values in the 100 multiplied by itself is a total of 4 place values after the 1. Okay, what's 50 squared? 5 times 5 is 25 times 10 times 10 again, so it'd be 2,500. And that's going to be equal to C squared. So I add these up. What's 10,000 plus 2,500? Okay. And then you get to this point here, how do we figure out what C is equal to? We would not divide it by 2, because that would be finding out what number times 2 is equal to that. We won't divide it by itself because that will give us 1.
Divided by 4.
You're close, Clover. What did you say?
Find it by square root.
You find it by finding the square root. Because the square root of C squared is C. Therefore, we have to find the square root of 12,500. So reach for your calculator. Go, go, go. Unless you can do that one in your head. I'm not doing that in my head. Round it to the nearest whole number. What would you have? 112?
Yes.
Okay, so then we're going to say it's squiggly equals because we're rounding. So that's going to be 112. So it's going to be about 112 yards to go diagonally across the field. this is the one step here you've got to pay attention to. We're taking the square root when we remove the exponent. Multiplication and division are inverses. Addition and subtraction will undo each other. And if you square a number, taking the square root will take you back to where you started. Let's do one more. Different question for you. Do the side lengths of 6, 11, and 14 make a 90-degree angle? I'm sorry, not make a 90 degree. Make a right triangle is what I meant to say. Six, 11, and 14, whether it's inches or feet, it doesn't matter. But if you had a 6, 11, 14 triangle, will that be a right triangle? I see one person doing this, and I see another person doing that. How do you prove it?
Try to do it.
Try to do what?
Make the triangle.
And that's one way. But I want you to prove it using algebra. Clover?
Last year did we do something like this, like 6 plus 11 if that's more than 14, then it can't be a triangle?
Oh, well, any two of these added together, if it's greater than the third, will allow it to be a triangle. So that can make a triangle. The question is it going to be a right triangle?
No,
Why not?
because I drew it and it does not look like, wait,
Yeah,
hold on.
I don't want it drawn. I want you to prove it using the math. I want you to prove it using the Pythagorean theorem. So this only works for right triangles, correct? So if you plug these numbers in, let's do it. If you plug them in, that's going to be a true statement.
Oh, so it is.
Is it a true statement? What's 6 times 6?
36.
What's 11 times 11? 121. What's 14 times 14? 196. So does it work?
No.
No. So these are not equal, therefore it does not fit the Pythagorean theorem. Therefore, it's not a right triangle.
Would it have to equal 14 squared?
Well, if this equals this, then it fits the Pythagorean theorem. But it doesn't, therefore it's not a right triangle. So that's kind of working backwards from what we're told. We're told that this is going to be true for all right triangles. If the statement is not true because of the measurements, it's not a right triangle. And when you do your drawing, it might have looked close, but we're not using drawings. We're going beyond that. We don't want to have to draw everything that we are going to possibly ask questions about. We want to use formulas and theorems.
Wait,
Yes?
so the Pythagorean theorem, it has to equal 180 in order for it to be claimed as
No. Any triangle, the sum of the three angles will be 180 degrees,
yeah.
okay? And I gave you that because you might be given a triangle that's like this right here. And they don't tell you whether it's right or not. And they say that this is 30 degrees, and this is 60 degrees. And they ask you, could you use the Pythagorean theorem for that triangle? Yes or no? If all you're told is that this is 30 and that's 60,
Yeah.
why can you?
Oh.
Because it's a right triangle. Because 30 and 60 adds up to 90, so this has to be a 90.
Oh, I get it.
So now if I knew, for example, that this was 4 and this was 8, it wouldn't be with a 30, 60, 90, but let's just say it was. You would be able to figure out what that is. Because that number squared plus that squared will equal this squared. So if, for example, we had these numbers, 4 squared plus 8 squared will be equal to x squared. What's 4 squared?
60,
8 squared?
64,
Add them up.
80.
80. Okay, now we take the what?
You take the square root.
Take the square root.
Oh,
What is it going to be about? What's the approximate square root of 80? No, don't use a calculator. This one you should be able to do. Yeah, it's really close to 9, isn't it? Because 9 times 9 is 81. Good.
Wait, so it's not always gonna be exact? It's gonna be like an estimate?
Well, in this case, it's going to be an estimate because we can't give you a perfect square root of 80. This, where was it? The 3, 4, 5 is real nice. The 6, 8, 10 is really nice. The 9, 12, 15 is really nice. But not everything is going to be whole numbers. And then as soon as we take the square root of something which is not a perfect square, it becomes an estimate. Are you guys listening way back there? This is part of preparing you for your homework as well. As soon as you take the square root of something which is not a perfect square, it becomes an estimate. And perfect squares are 1, 4, 9, 16, 25, 36, 49, etc. Because this is 1 squared, 2 squared, 3 squared. Now, anything other than the square roots of these becomes an estimate. Most anything. All right. You need your homework. Page 99. Page 99, 2 through 6, 9 through 11, 15, 16, 18, and 20.
I could drop my pencil off and disappeared. That's a little bit strange.
What's strange?
Like whenever you drop it, like missed it.